Right, now we're on to section 2 of transformations. We're looking at another kind of transformation called a rotation. Now for a rotation, we need to know the degrees, the direction, and where your center is. Now luckily for us, our center, this spot, will always be the center, the origin, right here. So this one is just showing us kind of an example of what a rotation might look like. So you can see going from B over to B prime, it kind of rotates around. It makes a circular motion around the center here. Same thing, A going all the way around to A prime, and C going all the way around to C prime. Okay, so everything is just rotating, or it's just kind of sliding around this center piece. We're pretending this is kind of the focal point, and everything else is just kind of sliding or rotating around that spot. Now we need to know the angle, so how much we're rotating around, and we need to know the direction. So the direction will always be clockwise or counterclockwise, and the angles that we are going to use will all be multiples of 90, so either 90, 180, or 270. And we have a rule for each one of these. So our rules, if we're going clockwise 90 degrees, that's actually the same as going counterclockwise 270. Let me show you what I mean by that. If this is our center point, that's 0, 0, and here was our pre-image. That was the original dot that we were looking for. Now, if we are going to rotate this, then 90 degrees clockwise. Well, clocks go around this direction, so 90 degrees this direction would get us right here. So this would be our image. This would be the new spot. And notice, it makes a 90-degree angle. If we go from the image back to the center and the pre-image back to the center, it makes a 90-degree angle. Now that's the same as if we were to go all the way around the other direction, counterclockwise, 270 degrees. This is a 90-degree angle, so going the rest of the circle here, this would be a 270-degree angle. So these two mean the same thing. Counterclockwise 270 is the exact same thing as clockwise 90. And the rule for that is, let's say we had a dot here. We're going to pretend that it was at 2, 4. Okay, so that's its original spot. Okay, as we rotate clockwise 90 degrees or counterclockwise 270 degrees, we would say t of xy becomes t prime of y negative x. So these two switch spots, our y becomes our x becomes our y, and then the new y spot, which was our old x, becomes negative. So what does this mean? What does this look like? Well, we would say that our new spot, which I guess I could label down here too, is actually going to be at 4, negative 2. Okay, so if it was at 2, 4, and then it rotated 90 degrees, it would now be at 4, negative 2. So, going on to our next one then. Clockwise 180 degrees is the same as counterclockwise 180 degrees. And again, that should make sense if this is our centerpiece. Here is our pre-image, that was our original one. If we rotate 180 degrees clockwise, so going the direction the clock would go, gets us right here to our new image. Now that's the same as if we went counterclockwise 180 degrees. So counterclockwise 180 is the same as clockwise 180. They both, so we go across there, it makes a 180-degree angle, just a straight line between those two. And the rule for these is going to be t of xy becomes t prime of negative x, negative y. So whatever values you had before, they stay the same, or at least in the same spot, they just become negative. So I'm going to use the same numbers. Let's say we were at 2, 4. It would now become, negative 2, negative 4. Using our rule, the x value and the y value, they stay in the same spot, but they both just become negative if it rotates 180 degrees in either direction. All right, then the last one we're going to look at. If we have our center right here, our pre-image off to the side, And if we are going to rotate clockwise 270 degrees, that's the same as going counterclockwise 90 degrees. I'm actually going to show you the counterclockwise one first. Might be a little bit easier. It just means we're going in this direction that far. That would help us find our new image. So again, that makes a 90-degree angle going from our pre-image to the image. Now if we go clockwise to get to the same point, it's actually 270 degrees. So clockwise 270 is the same as counterclockwise 90. So you need to be very careful. Just because they say rotate 90 degrees, it really makes a difference if it's clockwise 90 or counterclockwise 90. So make sure you understand what each question is asking. So if we're rotating 270 degrees clockwise, this is what our rule would look like. T of xy now becomes t prime negative y x. So again, if this spot was at 2, 4, the x and the y spots switch. So 4 here, 2 here, and it's the y that now becomes negative. So over here, it was the x that became negative. For this one, it's the y that becomes negative. So those ones will just kind of flip on each other. So those will be our 3 rules for our 3 different kinds of rotations. There's technically 6 different kinds of rotation, depending on if it's clockwise or counterclockwise. And then you use 90, 180, and 270. But all in all, together there are 6 of them. So 3 rules that we'll use. So looking at a couple examples, we need to rotate this triangle MTN below. Right here, we're going to rotate it clockwise 90 degrees. Note the coordinates of the new vertices. So here's the coordinates of the old vertices. If we're going clockwise 90, this would be our rule. T of xy becomes t prime of yx. I'm going to move our rule down here as we kind of plot these new ones out. So as m slides around 90 degrees clockwise. So going with the clock, it's going to go this way, 90 degrees, and land right up here. This would be our new M spot. We'll call it M prime after it rotated. Again, the spot that we're rotating around is the origin right here. There are ways to rotating it around different spots, but we won't go into those ways during this course. Now, the next one, if we look at T, it is at -2, -2. So as it rotates around 90 degrees, it'll land right here. This will be our new T value, or new T spot, so it's called T prime. And same thing with N. N is going to rotate now. And let's see, we'll use blue. Land right here, so this would be called N prime. Okay, these would be our new spots for each of them. So, I guess we can even connect these. Draw out our new triangle. This is our new triangle after it rotated around the center. You can almost see how we kind of grabbed it from here, slid it all the way around, and rotated it into a new position up here. Now, let's write down what each of these spots would be. M prime slid from M. M used to be -5, 0. So, using our rules, the x and the y switch, and whatever was the x value is now negative. Or at least, I should say, the opposite of it. So if it was a -5, it'll now become a -5, which would make it positive. So +5 will now be in the y value. Whatever was the y value, 0, now becomes the x value. So 0, 5, which actually fits. That was exactly where we landed on. So we used the rule on the old point, and that's how we found the new point. Same thing, using n. If we were at -3, -4, those two are going to switch. I'm going to use blue this time. So those are going to switch, -4 and -3. We just flip them around, but the x value becomes the negative version. So it actually becomes a positive 3. Negative 4, positive 3, which again fits. We're at negative 4 and then up 3 to find our new end spot. And lastly for t, again, negative 2, we just switch those two and then make the x value, or the one that's in the new y spot, we're going to make it negative. So it would actually be at negative 2, positive 2, which again fits. We're at x is negative 2, up 2 spaces for our y value to be positive 2, and that's the new value of t. So these would be our m prime, n prime, and t prime, and this is what the whole thing looks like. Let's do that again though. We've got this figure j, u, p, k, and we're rotating it counterclockwise 180 degrees. Note the coordinates of the new vertices. Well, again, this is going to be t of xy becomes t prime would be negative x, negative y. That's our rule for each of these spots. So if u was at negative 4, 0, j was at negative 5, negative 2, k was at negative 3, negative 3, and p was at negative 1, negative 2. Well, this time we're going to do it a little bit differently. We're going to plot our points first. So where u used to be negative 4, 0, u prime will now be at positive 4, 0. Whereas j used to be negative 5, negative 2, j prime will be positive 5 and positive 2. K was negative 3, negative 3, so k prime is now positive 3, positive 3. P used to be negative 1, negative 2, so p prime is 1, 2. So we used our rule to find all the new points. Now we can just plot them out. So u would be at 4, 0 right here, or should I say u prime will be right here. J prime will be at 5, 2. K prime will be at 3, 3. So 3 and 3. And P prime will be at 1, 2. Oops, hard to see that P. There we go. Now if we just connect all of these, that would be our new figure. And again, you can kind of see how all of this together was just basically rotated 180 degrees around the center right here. We just moved everything all the way around the center to get to our new spot, and here were our new values. We use the rule to find our new values, and you can plot them on the graph here. And that'll actually cover it for 10.2.